Hello, my name is Rishika Banerjee, roll number 160101222012, and I am presenting my BCT IA2 with my teammate Arushi Savla 160101238812. Our topic is the blockchain-based decentralized voting system for class representative elections, and we developed the application called EduChain Vote. So this presentation is a comprehensive architectural overview and the research foundation. And there was a grounding solution which was established in research and frameworks. We wanted to leverage blockchain's immutability for tamper-proof elections. We also used a very modern, robust technology for implementation and scalability. And we wanted this application to ensure there is transparency to make the electoral process fully auditable and verifiable. So, a decentralized approach to academic governance. Our application is called EduChain Vote, which is a blockchain-based decentralized voting platform. This system is basically designed to facilitate elections and to serve as an educational showcase for decentralized applications and the development of such in blockchain utility. So it's developed by me and Arushi, and the date of review today is 21st October 2025. So some of the technology stacks we've used is Ethereum, React, Hardhat, and MetaMask. So as we do not own any Ethereum wallets, we have created dummy wallets and used the dummy wallets on the application. The motivation and background was to address the flaws of traditional systems. So in most schools and colleges, there is critical processes like class representative elections which are conducted through traditional paper ballot, and it's a centralized digital system. So these mechanisms are very vulnerable because manipulations can attack the integrity of the democratic process. So on our to cite our research paper by El Kafali, conventional voting mechanisms suffer from cost, security, and transparency issues, making them prone to manipulation and distrust. Our main problem definition was the hurdles of centralized election, and we identified the main five critical shortcomings in the current class representative election method. So we have chosen to address the lack of transparency, the verification challenges, security vulnerabilities, centralized authority, and limited auditability. And our research foundation was blockchain as the trust anchor, based on our paper where it ensured that blockchain technology provides a strong decentralized foundation to overcome pervasive voting challenges through its inherent properties. So the challenge in traditional system is data tampering and manipulation, and blockchain capability is cryptographic hashing and linked blocks. So the advantage it gives is immutability. Then when there's a lack of trust and authority, we use distributed ledger technology. Again, the advantage is transparency where all transactions are visible to all participants. Centralized control is a challenge in the traditional system. So in the blockchain capability, we use peer-to-peer network structure, and the advantage is decentralization. So no single entity controls the voting outcome. And also there is no cryptographic verification. Smart contracts and digital signatures ensure that it's verified and there is cryptographic proof.
These principles form the backbone of our project, translating theory into real-world educational application. Project objective: EduChain Vote was built with three primary goals: eliminate central authority using smart contracts to enforce voting logic automatically, enable verifiable results, allowing every student to confirm their vote was cast and counted correctly, promote blockchain literacy, helping students learn how decentralized applications function through hands-on experience. So this system isn't just about election, it's also a learning tool for blockchain education. Here's overview of EduChain Vote, the decentralized workflow. Here's a simplified workflow. Students cast votes through a secure web interface. Each vote is recorded as a transaction on the Ethereum blockchain. A smart contract automatically validates the one vote per student rule. Votes are instantly visible and immutable on the blockchain. The admin dashboard simply displays verified results. It cannot modify them. This ensures complete transparency and eliminates any human bias. System architecture, three interacting layers. The architecture of EduChain Vote is divided into three distinct yet deeply integrated layers to maximize security, usability, and operational reliability. Front-end or presentation layer built with React and styled using Tailwind CSS. This layer focuses on providing a secure, intuitive, and accessible user interface for students to cast their votes and view election results. Blockchain layer, the core logic is written in Solidity and deployed via Hardhat. This layer manages the voter registry, candidate lists, and immutable counting mechanisms enforced by smart contracts. Interaction layer, communication, facilitates communication between the front end and blockchain network. Web3.js is used for method calls, and MetaMask provides secure, decentralized identity and transaction signing. The technology stack, we used a modern full stack environment optimized for decentralized applications, React.js for dynamic front end UI. We use Solidity for smart contract logic. We use Hardhat for testing and deployment. We use Web3.js for blockchain connectivity. We use MetaMask for secure wallet based authentication. And we use CSS for fast and uniform design. Together, these technologies create a real world prototype for decentralized academic elections. Thank you.
So here is a quick walkthrough through the application. So we can enter as an admin or as a student and we can view the live results. This is a little bit about the application where it's one student, one vote, it's immutable results and a public audit trail, which are the main functionalities of blockchain. And this also explains how it works for students. And here are some blockchain concepts which are like interactive demos to understand how blockchain voting works. So there's cryptographic hashing, where you can create a chain and then you can tamper with the block, and then it will say that okay, the chain integrity has been broken. So this is just to sort of ensure that someone understands. And here there is an interactive hash calculator where you can type anything. So if I type Rishika, if I type Rishika, so with each letter it changes. And this is how there's an avalanche effect that is shown. This is just one part. There is also the public key cryptography, which teaches how key pairs work, what is a private key, what's a public key, how digital signatures work, and what's the address derivation. So this is just a learning and understanding of how the key concept works. And there is also a consensus mechanism which shows what the how it works. So it shows that if you have to mine a new block, so then there are different nodes. So how are they mining? So from so the chain with the most blocks is considered valid by all blockchains. So here it just shows like a demo of how consensus mining works. And we can stop mining. Yeah. So we will first enter as an admin and we will start the election process. 1, 2, 3, 4 is a demo pin. Here there are 5 registered voters. We will start the election. Then we go back and we will connect and enter as a student. So here we have 5 voters, that is 5 students, and their demo wallet. So now we're going to come in as Alice Johnson and we can select out of these 3 candidates any one. So let's go with Maya Patel. So once we confirm the vote, we get the understanding that okay, this is the block that has been created. The timestamp is it's 12:23 p.m. on the 10th of on the 22nd of October. So here, as you can see, it is properly timestamped as today is 22nd October 2025 Wednesday, and it is 23 p.m. Then we can go and view the current result. So this is something that is shown, that it's okay, one total vote cast, one transaction, 20% turnout, and the actual live result. Now we can see the whole transaction history. We can go back and log in as another student. So as we can see, Alice Johnson has already voted. Now let's say we want to be Bob William, so we can cast a vote for David Kumar. So we confirm a vote. Same process, the transaction is pending, it's been created 12/24. Okay, then we go back to home. We can cast our third vote as Charlie Davis. And let's say we go for Maya Patel again. So now we can check and see the whole transaction. We can see view current result. So per person, as you log in, you can see the whole ledger. The who's voting for what is anonymous, but what the transaction is, that is visible and understandable, and it's shown. And the whole transaction detail is shown and how it has been confirmed. So there's a demo net, that is the EduChain test net, and this is the blockchain verification. We can also see how blockchain prevents fraud, and we can educate ourselves on that. This is one section which teaches us about how the blockchain contains data, hash, previous hash. So this is a little bit of the knowledge base which helps students understand how blockchain works and what the entire concept is. Now we can enter as an admin again, and we can end the session, and we can check that what is the audit log. So when we view audit log, we can see that this is the three transactions that are shown with their block number, with their timestamp, and their action and their hash. And here we can also check the whole ledger. And the election winner is Maya Patel, because there were two votes that went to Maya and there was one vote that went to David. So this is our application, and we do want to make this into a proper large scale final deployable product. But thank you so much, and yeah, thank you.